All right, thanks for joining us, everyone. I'm Mike Mimoso, the editorial director here at Claroty. And with me shortly will be Grant Geyer, our chief strategy officer. We're going to spend a few minutes today talking about two important developments. First is the publication of a new paper called Resolving the CPS Identity Crisis, CPS, of course, being cyber physical systems. The paper looks at what we believe is an industry-wide issue regarding inconsistencies in digital naming conventions that are used by OEMs and medical device manufacturers. We're seeing evidence of the impact of these inconsistencies when it comes to CVE attribution, for example. We're seeing incomplete and partial matches of CVEs to affected products. And we're going to talk about how this impacts overall risk reduction. We're also going to spend a few minutes talking about Claroty's new CPS Library, which is essentially a repository of asset information and identifiers that we hope goes a long way toward addressing these last mile remediation challenges that a lot of CPS asset heavy enterprises are dealing with. So let's get our presentation going today and bring in Grant.
Hey, Mike.
Grant, good to see you. How you doing?
A little chilly and a little bit of snowy here in
Yes.
Washington, D.C.
Tis the season, right?
Yeah.
So let's get started. I mean, this is a pretty nuanced problem that's impacting cyber physical systems protection and how these systems are managed, especially around risk. Just big picture, how do you characterize this issue? What are some of the problems that enterprises are facing when it comes to these particular last mile remediation issues?
Yeah, I think it's important not to think about CPS only as individual assets, but trying to think about it as the overarching system that needs to work together. And when I think about that system, a lot of times it's like engineering workstations and HMIs or SCADA systems that are probably going to run on embedded Windows devices. And then there's the components themselves, the PLCs, the RTUs, a lot of the more line level systems. Now, when I think about the HMIs and engineering workstations, a lot of times people might look at the operating system level, might do a scan of that system to say, what is it and what needs to be done? But unless you have access to the system itself, you don't know the KB level. And even if you know the KB level, it doesn't mean you can patch to the latest one. You actually have to go to the OEM's website to understand what the specific certified patches from the OEM. So that's kind of one part of the problem. The second part is really kind of around the components. And there you need to both, what we figured out is you normally just look at manufacturer, model, firmware level to understand the CVE level, the vulnerability. But what we figured out is that a lot of times that's not enough. You really need to get down to the actual product code. And what we've seen is that quite frequently, the product code is not included in a lot of the data on the cyber side. Now, making even this problem more complex, when you go to the OEM's security advisories, a lot of times the product code isn't there as well. So you're kind of missing information from both sides of that equation. And you would think that the National Vulnerability Database would have the necessary information in it. But what we found is a lot of times it's not there, and it can lead you to inconsistent results and create work to try to figure out, either create work that you don't have to do to patch, or not knowing that you actually do have to patch. So it's a really complex problem when you look at both sides of this equation.
Right. And I would imagine too, the different ways that data is collected from these systems kind of impacts or exacerbates the problem a little bit. I mean, I'm sure there are multiple aliases for the same asset, for example.
Well, look, I'll talk in particular about industrial environments. A lot of times people use passive collection in order to sniff the traffic and figure out what the actual model firmware levels are. But what we've seen is a passive collection, with passive collection, you're totally reliant upon what the OEM decided to put in that session 20 or 30 years ago when they designed these protocols.
Right.
So a lot of time that information is missing, which is why people do active queries, safe queries, get a project file information. But what we figured out is the more sources you get actually makes the problem even more difficult, because There's inconsistent naming conventions in each of these collection methods because it wasn't designed to do that by the OEMs. And so you may have 4 different aliases for exactly the same device. And this has actually found its way into the National Vulnerability Database. We found examples of the same exact asset listing different vulnerabilities and different CVEs. And so it can become a really confusing picture with not having a single source of truth.
Mm-hmm. And then the security team, the security analyst, like you said, has a lot of manual work on their hands in trying to connect CVE information, for example, to the right affected product or version.
You have 4 different aliases for the same device. Well, how do I take those 4 aliases, figure out what is the right one? Now, how do I figure out if there's a CVE actually for it? And is the National Vulnerability Database correct? So I might need to go to the vendor's advisory, but the product code might be missing there as well. So, and that may just be for one class of assets. So think about being in a large enterprise, multi-site with hundreds of different vendors. It's really a problem that simply when you think about all of those complexities, it's really almost impossible to solve this problem accurately without having kind of a single source of truth.
Mm-hmm. And we should mention too, you can get a lot more in-depth information about this problem by downloading the paper on Claroty.com, a lot of the data that we came up with. But let's talk a little bit about the research, Grant, in particular, how our AI-driven techniques, along with our protocol knowledge, especially around OT, how it, we were able to fill in some serious gaps here, in particular for one OEM's device catalog that we had access to. I think there's a good story there to tell.
Yeah, look, when Claroty started in this market space about 10 years ago, our people were thinking to themselves, that our research analysts were like, look, we have to be right every single time because employee safety depends upon this, and in healthcare, patient safety depends on this. So we got to be right every time, and that led us to a lot of human-based work. But when you see kind of so many different IoT, OT, medical devices out there, so many classes, you simply can't do it with humans alone. And so we started changing our methodology to having multiple different analysis models and doing what we call establishing statistical inference models, where each model doesn't need to be 99% correct. If you can get multiple models and each are, let's just say, 70 or 80% confident, when you layer them on top of each other, you can get to a product that's 99 or 100% confident in your results. And some of those things, for example, the use of LLM RAGs. So it's a mouthful, but it basically is the newest versions of LLMs are referred to as retrieval augmented generation. Rather than asking the universe a question, of the internet universe a question, you feed information into the LLM specific to the domain and then asks certain prompts. And with the right prompt engineering, you can get to really interesting answers. So an example here's in the Japanese healthcare market. We did our first POV. No one on our team spoke Japanese. We didn't know a lick about Japanese medical devices. And we fed in everything we could find about Japanese medical devices. And we had the LLM with the right prompt engineering. Yeah. We're able to get to 97% accuracy in our first POV is one example. And if you kind of layer into that, other models where you by doing what we call human machine teaming, our researchers know what the traffic looks like for a skater, what traffic generally looks like for an HMI, or for PLC. And when you pick the right features of data, that's another way to infer what the asset actually is. And by having multiple models we layer on top of each other, you can get to really concrete examples. And so this is where know-how plus an enormous data lake plus AI techniques enables you to go after what we consider the BHAG, the big, hairy, audacious goal of mapping the entire universe, which we'll talk about in a second. Now, one specific example we talked about here with one OEM, we found that only 4% of the time the manufacturer had put the product code in the traffic. And by filling in the blanks that were missing in the advisories and the CVE information, we got from 4% product code mapping to 83% product code mapping. Now, why does that matter? It matters when it actually came to being able to map the risk. So with the newly matched product code, we got to 56% of devices from this one OEM. We were able to get new security information or updated security recommendations, such as like getting the right firmware level and what the right firmware level the customer needed to move to were. As a result of this, we also we improved our vulnerability identification accuracy 25% by having the right single source of truth at the heart of it. And so if you start doing this vendor by vendor, you improve the overall accuracy, you understand your true risk level.
Right. It's really powerful. Yeah. All right. So let's wrap up and talk about the CPS library overall. And just maybe, I think we've kind of talked around it a little bit, but it really fills a need by providing that centralized repository of asset information. Talk about that and just how it improves overall risk reduction. I mean, I think we've hinted at it throughout the conversation.
Yeah. So the goal here is, right, you have to get your asset inventory correct. You need to have the correct product code mappings for that inventory, and you need to figure out from the security advisories how that maps in. And again, there's a lot of data missing in all three of those pools. So using a broad range of techniques, many of which are AI based, we're able to fill in the blanks in all three sources of data and connect those dots. This has enabled us to build it's an ongoing project, but the CPS library, we want to map the entire universe of OT, IoT, connected medical devices, building automation systems, so that with one central place, you can know what is the asset, what is the right firmware level it needs to be on, what are the default passwords that need to be changed, what are the right patch level it needs to be on, according that is certified by the OEM. So our goal here is to remove a lot of that last mile inefficiency and drive a more accurate risk remediation program for the asset owner.
And I know some of the folks that have seen early versions of this and gotten to play around with it are pretty excited.
Yeah, we totally think it's a game changer. Fundamentally, what I think the message we hope to convey is that in all of this data is that the foundations of which CPS risk remediation are done is broken. And what we're trying to do with the CPS library is make sure the foundation is solid by providing accurate, well-mapped information so that asset owners don't need to go through the toil of filling in all these blanks themselves, one device or one vendor at a time.
Right. All right, Grant. I think that's a good place to leave it. I want to thank you so much for the time and the great information. And I want to thank everybody for joining today. And just another reminder that you can get the paper that we're referencing and talking about on Claroty.com. So once again, thanks everybody for joining and have a great weekend.
Take care.